So Palo Alto Networks, company that has firewalls, they're like super fancy firewalls. So instead of just doing the basic like source destination filtering, they do much deeper packet inspection. So they can, for example, only allow a specific protocol on a certain port, or they can even do like HTTPS decryption on board, meaning that they could detect if you're going to some malicious site that uses HTTPS. They can detect malware being sent in emails and things like that. So lots of fun features. So layer 3 versus layer 2. Layer 3 is network, so that's like IP and stuff. Layer 2 is data link, so that's like MAC addresses and stuff. Yeah, very brief. So basically, layer 3, Apollo at layer 3 means that it's going to actually do routing, it's going to have an IP address, it's going to be visible on the network somewhere, so it's probably going to be the network gateway or something. Apollo at layer 2, or as a vWire, means that it's going to be, for all intensive purposes, invisible on the network. Apollo as a vWire, the only thing that you can see is the MAC address for it, and on the network, unless your packets are being blocked, you can't necessarily tell that that is Apollo. I mean, without like looking up the MAC address, fend or whatever. But you don't necessarily know that there's that firewall on the network. You can't really see the device on the network. So there's some benefits to both of them. So where would each go? First of all, in like just your standard network configuration, for mocks we use one-to-one NAT, which means that we take some subnet, so like 10.20.1.1/24 for the team, meaning that you get 10.20.1. And then the last digit is whatever the box number is on the team. And then we map that using one-to-one NAT to 192.168.0.1/24. So Palo at layer 3 goes right here. It acts as the router and it acts as the firewall. It does that NAT routing, it does DHCP for the internal network, and it does all the firewall stuff. Palo at layer 2 goes in between the router and the network. So we have this separate router, probably a PF sense, since we like to use PF, that does the NAT. This does DHCP, this does routing. Then the Palo just sits here effectively on the wire in between this and your switch for the network, and monitors traffic, blocks traffic, stuff like that. So a layer 3 Palo is great if you're, building the network from the ground up, or you have a lot of control over stuff, you have a lot of time maybe. Layer 2 Palo is probably going to be better if you need to like insert it in the middle of a network that's going on. It's a lot easier at CCDC because the routers are already set up and you might not actually have access to the routers. And this way you can just plug this in. It acts as basically an Ethernet cable using vWire mode and can block packets, do packet inspection. So I deployed a VApp to everyone. Let's see. Shane, did you deploy? Oh.
Yeah, is that case sensitive?
Probably. Nope.
Oh, you're filtering on state partially running.
Oh, haha. There we go. All right, so should probably turn this on. Palo likes to take a very long time to start, which is great. Oh, that's not good. No clue what that means. Hopefully that is not broken.
Does not comply.
I assume that's something to do with the amount of cores it has, maybe? Not sure. All right, let's hope that it's not broken. Yay, deploying broken environments. That's never happened before. So this will take forever to turn on. So right here, I built this network. This is the VApp. We have, it's basically a mock network of our competitions. So this right here would be the DefSec router that is in a separate VApp from your team's VApp and controls routing between the red team network and the blue team network. You normally wouldn't see this. You would just see this. This blue box is like what you would get in your VApp during a competition. So this VApp has all of it, just so that you can control each part of that. Just really, haha, there we go. So in here we have the Palo box, we have the scoring engine, and then the routing between here. We're only going to be focusing on these two firewalls. Everything else should be set up and working, assuming that not every part of this VApp is broken. It's getting deployed. So did everyone understand what I was saying about NAT, one-to-one NAT? Sweet, I'm going to take that as a yes. Awesome. Glad people understand one-to-one NAT. So for our competitions, each team is given this octet is what their team number is, so 10.20.1 or .2 or whatever. Slant 24 one-to-one NAT to go between these two, which means that for a Palo right here on layer 2, they are going to be blocking traffic based on your internal IP address, and then Palo is kind of fancy in that if the Palo is here and it's doing the NAT on board, it blocks it based on your external IP address, which is something that we will keep in mind for later when we get to blocking. Looks like this has hopefully started up. Awesome. So we're going to do the vWire Palo first. So go ahead and start, if you're following along, pfSense and vWire Palo Fresh. It's going to take forever to turn on, most likely. So I can maybe. But interesting. Oh, it was just, aha, that makes sense. All right, so when the Palo's starting up, go ahead and open the web console for it. You can watch it take hours to boot. This demo is probably going to be a lot of waiting for things to load. I'm not sure what they did, but with the latest version of Palo, everything is significantly slower. Yeah, so more on the network. So these boxes are, of course, your team boxes. You have your router, red team. For this, we only have 2 boxes just to make it a simpler environment. Let's see. What else? Oh yeah, so the management interface. Palo has a management interface, which is different from pfSense. So pfSense, when you want to change settings on it, you just go to 192.168.0.1 in your browser or something like that to log into it. Just one of its 2 interface IPs. And then that interface generally has access to the admin panel on it. Now that works fine for like a home network or a smaller network. But when you start getting into big corporate networks, you don't necessarily want everyone on your corporate LAN to be able to access your firewall settings, something like that. I mean, DSU, they don't want, I don't know if they actually have it set up this way, but they probably don't want every student to be able to access the management interface login page. And just in general, like security better if people can't just log in. If they take away your access to the login page completely, then a lot harder to break in. So they have a management interface. For our purposes, we just put the management interface right onto the LAN. We don't have a client box dedicated to the management interface, and also that makes it a little bit harder on red team. And we want to assume that red team would somehow be able to access that management interface on a different subnet or something like that deployed in a corporate environment, or that the Palo was just set up wrong and the management interface was open to the public. So what this means is that if you try to log in to this page, 192.168.0.1, that's just not going to work. That isn't hosting a web page there. It only hosts on this management interface unless you tell it otherwise. In a real environment, like at Nationals, when they give you a physical Palo, then you could just plug like a laptop right into this management interface. But for our purposes, it's just on the network, so it's going to act as another host on the network. So it looks like it's started up. Let's see if we can log in. So it's going to be admin and password 1bang. Hasn't started up right. So Palo is a little bit strange in that it takes forever for the login servers to start after the box has started, which means that it'll just tell you login incorrect even if you type the right password. Kind of confusing, makes debugging a little bit annoying because you can't really tell if it's because the login servers haven't started yet or if it's because your password's actually incorrect. I timed it and it takes anywhere from like 30 seconds to 5 minutes. So yeah, fun stuff. Still down. Any questions so far? Don't have questions pulled up on my phone, but
When you said intensive purposes, did you pronounce it intense and purposes or intensive purposes? That's my question.
For all intensive purposes, for all of our purposes
That are intensive.
that are for all of our uses. Is that better, Shane?
What'd you say? No, what'd you say though?
For all intensive purposes.
So purposes that are rigorous.
Sure.
Okay.
All right, so it allowed me to log in. So initial setup. The initial setup is going to be on the command line. Palo does automatically set the management interface to be 192.168.1.2, but our network isn't currently configured that way. So we're going to set it up from the command line, and also it's good to know this. So Palo command line, kind of interesting. I went over this last time. Instead of being it's a custom kernel, so like the commands you can do are very limited already. And then in order to change anything, you have to go type configure to enter configuration mode. In configuration mode, it's kind of like a directory structure. So this is all of the configuration. There's a ton of it. But if you want to edit a certain area, so like say you want to edit the user admin and change their password, you can go edit, management, config, users, and then, edit management config. There we go. Can't edit users. Haha. So this kind of puts you into that directory. So now if you do show, then you can see all the users on the system. So it's a good idea to change the admin password right away, because on a good Palo that doesn't have any vulns yet, the default password is going to be the biggest vulnerability. So you do set users admin password, then tells you to enter a new password. And I don't want to change the password because I'm going to forget it during the demo, and that's going to be awkward. However, it is a good idea to change the password. Next, so in order to get out of the folder and go back to the top of the config menu, you just type top. So now back at the top, and you can see right here, oh, my mouse does not appear. So it says edit, and then in braces it says edit management config, and then after that it says edit. So that's kind of like where you are in the folder structure. So we want to set its IP address. We're going to do edit device config system. And if we do show, you can see it's already at 192.168.1.2, but we want to change that because our network's not set up that way. So then we do set IP address 192.168.0.2, and then we also need to set the net mask, so we can do set net mask, and then we also want to set the default gateway. But instead of typing set and then thing and then the item each time, you can do multiple in one. So set default gateway to 192.168.0.1, and then we can also in the same line do DNS servers or DNS settings servers primary. we'll just set it to IALab DNS. All right, so after we do this, we need to go commit. So that's going to actually save those changes. It doesn't change until you do commit. So yeah, for debugging, make sure you commit your changes. Kind of nice because that means you can change a lot of settings or apply a lot of firewall rules between commits or change something between commits without it immediately committing, so you can like change a few things at a time. It's kind of nice for if you're like setting up a new interface, you don't want to enable the interface and then enable one firewall rule on it and then enable the next one. You want to enable all of them at once, maybe, or maybe you want to do them one by one. So then you got to remember to commit between. So that should be enough for this. We can close out of that and then open GUI, which hopefully is not broken like IALab says it is. Yay, looks to be working. So now we're on to the GUI. Currently, this does not have an IP address. DHCP isn't configured and this can't route anywhere. So we need to give this box an IP address. So in case you didn't know this, in Linux, if you have IP, then you can do this to get in a temporary IP address, which is really nice. I learned that recently and very happy with it. Now you don't need DHCP to get a temporary IP address. So, oh, that's awkward. There we go. Need to be root to do that. Right, so now we have an IP address. Right there, you can see 192.168.0.100. We're on the network. Now we can talk to this. In the browser, go to 192.168.0.2, and uh-oh, I messed up that. Okay, let's try that again. And that'll bring us to the login page. So here it's admin, and then whatever that password you entered is. Password 1 paying by default, of course. And this will log you into the GUI. Takes a little bit, sometimes. Okay, it's taking a little bit longer than normal. By the way, also, if you want the screen to be bigger, then you can do xrand r tac s, and then the size of the screen that you want, and that makes the screen bigger on Linux, which is kind of nice. All right, so high speed. There we go. It will have a bunch of annoying pop-ups telling you various important informations that we don't really care about right now. All right, here we go. Now we're logged into the web interface. So first thing to do, always change the password. If you want to change the password from the web interface, you go to Device up at the top, and administrators can change the password there. So we're going to set this up as layer 2. So we have a lot of checkboxes and lots of different GUI things. First thing we want to do is set up the interfaces. So if you go Network, Interfaces, then click on an interface, and then wait a little bit for it to load. Now we have this to configure the interface. So interface type right here, we want to set this to virtual wire. We don't actually want to set it to layer 2. That's for if we want to do VLANs and stuff, which we don't really want to do that. We just want to do virtual wire. So virtual wire, and then right here you need to select a virtual wire you want to assign it to. So this is like if you have a bunch of interfaces, you can have some connected to each other and others connected to each other separately of the first few. So we're going to add a new virtual wire, and just call this VWire, and then adds that, and then we're also going to assign it to a security zone. So each interface gets its own security zone, or I mean multiple interfaces can be in the same one if you want. So the first interface, Ethernet 1.1, is going to be on the WAN. That's your external interface. And then click OK through all that. Now this one, we can see it's virtual wire, and it's in the security zone WAN. And then we need to do that same thing again for Ethernet 1.2. Don't really understand why they named the Ethernet ports this way, but yeah, cool stuff. So again, interface virtual wire, interface type virtual wire. We want it to be on that same view wire. And then we're going to add a new zone called LAN this time. Internet 1.2 is your internal network. That's your LAN. You can actually see this if we go over, not there, network diagram here. So this is right here. We have 3 interfaces connected. The first one's the management interface. Then this one is Ethernet 1.1, which is connected to the external network. And then this one's Ethernet 1.2, which is connected to the internal network again, and that's going to be the default gateway. And then over somewhere here, nope, that's not the right one. There, the SPF is routing between the main network that has all the blue teams on it, and then this network, which is just connected between the PF Sense and the Palo. Right, so all those. Now, because we clicked Add New for the vWire and for zones, we should now see a new vWire here and a new zones here assigned to the correct interfaces. Now, the last thing we need to do is actually allow traffic to flow through this virtual wire. So over here, we're going to, next thing, allow all. So this is the policy security rules. I did not really go that in depth on this last time. So by default, there's these 2 rules, an intrazone rule and an interzone rule. So the intrazone is default to allow, and that's for going between the same zone, so LAN to LAN or WAN to WAN. So if you have multiple interfaces on the LAN or multiple interfaces on the WAN or multiple interfaces on whatever zone you're on, then this allows routing between those. Interzone is from one zone to another, and that's default to deny. So that's LAN to WAN or WAN to LAN or between any 2 other interfaces or security zones. Wow, okay. Words. So by default, it's allow and deny. We're going to actually just change this deny one to allow. So you go down here to override and actions, allow. And I'll explain the security policy rules more in a little bit. That should just allow traffic to route between the 2 zones. So this says that things in the WAN and LAN can talk to each other. Now, I think that's all the config we need to do. Yeah, that looks about right. So after all that, we need to commit. So go ahead and click this button up at the top here. That's commit changes. Always remember to commit changes, and it does kind of take a little bit. So hopefully this demo is not going to break again. I tried quite a few times over the weekend, and once when I did this step, it broke the VApp somehow. And yeah, I talked to Cloudman, and he came in and said that there was some weird thing with networking messed up, and it broke the VApp. I don't know why. I think it has something to do with the Palo was trying to grab same IP address as another thing. I'm not really sure how it works, but iLab does not really like when you switch, when you're doing super low-level routing. It prefers if you have like a normal layer 3 router. Layer 2 routing, iLab does not seem to like very much. I'm not sure why. So we are still on that network now, but hopefully, assuming that I didn't mess this up, we should be able to get a DHCP address. Maybe. Look at that. Haha. So we got a DHCP address. So back from lots of steps. Back to the network here. That means that from inside the network here, we were able to go through this layer 2 firewall and talk to our router, which means that we should also be able to like ping Google 8.8.8.8, which I have noticed extremely high packet loss when pinging things externally. I'm not really sure why. It might be, okay, that's kind of awkward. It's not pinging Google. Interesting. Let's try pinging something closer to home. I've noticed some really high packet loss through this, and I think that that's just some screwy settings with VMware and the Palo. As I said, it's not really like when things route on layer 2 inside the virtual networks. So I think that I might need to mess with some of the IALab settings to get it to route properly, but we do have a connection. A little bit buggy connection, but it's a connection nonetheless. So that is a V-wire Palo. Next. Yeah, super high packet loss sometimes. Next, let's do layer 3 setup. Layer 3 setup is significantly more reliable, I've found, and much less packet loss. So, yay. And, oh, actually, I guess I should pull up, well, yeah. So if we go back over here and kill this VM, powering off the layer 2 one, and then we're also going to power off that PF sense so there's no IP conflict, which causes IALab to not have a good time. And then we start one L3 Palo fresh, which is the layer 3 Palo. That'll take a few minutes to start up. Did anyone have questions on that so far? No questions. Awesome. So I did quite a bit of testing about the packet loss, and it seems like if I restart the entire VApp and like restart all the networking through IALab, then the packet loss gets significantly better or goes away completely, but that takes a very long time. And IALab does not like when you do a lot of layer 2 routing. It likes to control the interfaces in the network a lot and does not like when other people control them. It leads to some weird problems. It also leads to some problems if you if you like do DHCP yourself and then switch networks. Sometimes it will route stuff weird too, like if you switch networks while the VM's running. Networking is a little bit weird in the IALab. However, on a physical network with physical cables, it should hopefully perform a lot better. And that's kind of concerning. Let's hope it actually boots. Last time it just got stuck at this state and did not boot, which was not fun. All right. Does not seem very happy about that. Let's see, do I have a snapshot that I can return this to? Naturally, no. All right. Cool, so looks like the layer 3 Palo died during the template process. That happens sometimes. If you turn a Palo off from the IALab, it likes to not be very happy, especially if you turn it off while it's booting. So let's get a new layer 3 Palo. By the way, if you want a Palo to have fun with, then it's PA-VM10. That's not what I clicked. All right. PA-VM10. This one right here. Hopefully this won't take too long. Yeah, this looks like the other one that I had in here is kind of bricked. Yeah, super easy to brick Palo if you just unplug it and turn it off while it's booting. Pro tip, don't do that. When I went to push this template to the catalog, I think the layer 3 one was still running, and yeah. Right, so now we have an even more fresh Palo because it has only been in the catalog once. Look at that, fancy stuff. Maybe. high speed. There we go. So for layer 3, maybe, yeah, here we go. We want the first interface to be on the internal network, the last interface to be on the internal network, and then the middle interface to be on blue network, which is the network connecting all the blue teams together to the main router. Hope this one's actually going to work. Would be awkward if I bricked a second Palo. Where's that layer 3? It looks like it is powered on though, so that's nice. Hey, and starting. Look at that. So if it stays on that, like press any key to stop auto boot. If it stays on that for a really long time, that means that it is broken. I'm not sure why, but I think that during startup it like reads and writes to disk a lot, and if you just unplug it, then it somehow corrupts that. I'm not really sure though. But yeah, likes to break. All right. Well, that's starting up, which means that we get to go wait through this. So back to my diagram. So the layer 2 Palo, that one, pretty simple because all you need to do is say route from here to here. Layer 3 one's a lot more complicated. We have to set up NAT on it as well as DHCP if the network wants that, and stuff like that. And also it's all in one box doing the job of the router and of the firewall. So a little bit more config and in a way a little bit more importance in the network. Yeah, okay, this is slow. Probably should have given it more cores. In the meantime, well, we're waiting for this to, that's not what I meant to do. While we're waiting for this to load, I will go to the security policies. So security policies are basically the firewall rules. They decide what goes where. So in the security policies, you can set, of course, source and destination. You can set them to different zones or different addresses if you want. But then for what the application is, instead of having just an IP, or instead of just having a port like TCP 22 or something like that, you pick an application and it's like, it filters based on like that type of traffic for that application. So web browsing means that it only allows HTTP traffic over port 80. It's a lot more complicated to actually change the default port. But there we go. Yeah, so that's kind of nice because that means that it makes it significantly harder for red team to like tunnel something or put something over the wrong port and get through the firewall. Like that would work with the PF, not going to work with Palo. At this website right here, applepedia.polonetworks.com, it has a full list of all of the different things that has built in. So if we go to web browsing, right here, you can see it's TCP 80, but it also says that it's HTTP protocol. So yeah, a lot more restrictive. Let's see. Still not working. All right, give it another minute here. So this is a pretty useful site for searching for different free sets. You can also make your own. It takes a little bit to make your own. You can actually have it watch the traffic for a certain application and then like fingerprint it, kind of. But yeah, most of the time, one of the built-in ones is going to work fine. So it also has like RDP, MSRDP, or it has SSH, Hopefully it'll work now, maybe. Nah, I messed that up. Admin, password 1 bang. There we go. Now logged in. All right, so layer 3 setup. So layer 3 setup, first, oh no, failed login attempts. Who could that be, possibly? So first thing we need to do for layer 3 setup is the same initial setup stuff. Whenever you get a Palo, you're probably going to have to do this. So we're going to drop into configure mode, set management config users admin password, set the password, and then edit device config system. Oh boy, this is not very happy today. Set IP address 192.168.0.2 netmask and default gateway 192.168.0.1. Think that the DNS settings should be fine. We can commit that. While that's committing, let's hop back over to GUI, which I actually closed already. So let's hop back over to GUI. Maybe. There we go. And looks like we still have that IP from DHCP with layer 2. Yeah, so hopefully that doesn't expire while we're working. Can log in here. Oh boy. Yeah, kind of slow. Every time you change network stuff, has to wait for IALab to accept that you just changed it, and then it's slow. Where is, there it is, layer 3 Palo. Let's see. It's not committed yet, that is why. Also, Palo's slow. I probably should have given this one more course. Wow, it's like particularly slow. All right. Did it come across a problem? No. Nothing else seems upset other than GUI, which is still upset for some reason. Huh. That's kind of concerning. Must mean it's having a problem grabbing that IP address, I think. No, it has that IP address. All right. Interesting. Okay. Guess it showed up. Cool. Oh, there we go. Just committed. Gonna relaunch GUI because it went gray. All right, so same thing. Admin, password 1 bang, or whatever password you set. All right, so for layer 3 setup, oh my god, it's so slow. For layer 3 setup, instead of setting our interfaces to vWires and making new vWires, we're going to set our interfaces to layer 3 interfaces and then make a layer 3 router, which, when this loads, maybe. Wow, definitely needs more cores. More annoying pop-ups because it's a fresh Palo. All right, finally, so network interfaces. Ethernet 1.1, still going to be our WAN interface. Oh boy. So Ethernet 1.1, interface type this time is going to be layer 3 instead of virtual wire. And then for virtual router, we can just set it to default. It already has a default virtual router in there. And then for security zone, again, it's Ethernet 1.1, so we're going to set that to WAN. And under the IPv4 tab, this is where we set its static IP. So this is on the blue team network, so that's what your team subnet is. So we're going to set it to 1.20 or 10.20.1.1/16. So this is first one on your team's network. Then under advanced management profile, we're going to add a new management profile. So since this is an interface at layer 3 and actually has an IP address, which means that we can talk to it more so than just with a MAC address, then we can actually set things so we can interact with that interface. So this is we can enable the web interface on that. So that means that if you went to 10.20.1.1, you could get to the web interface. We don't want to do that. We do want to allow ping though, makes debugging a lot easier. So I'm going to call this pingable and allow ping. And then apply. Next we're going to do Ethernet 1.2, which is the LAN interface. Layer 3, again, we want to assign it to the same virtual router so we can route between them. And then we're going to make a new security zone. This one's going to be called LAN. Again, super fancy. Then under IPv4, still want it to have a static IP, but this time we want 192.168.0.1/24. You can actually make, it says new address, so you can make an address object, which allows you to name it something. I'm not going to do that for these first two, but I will do that in a little bit. I'm going to make that pingable again, and then apply this. So now we have Ethernet 1.1, layer 3 pingable, Ethernet 1.2, layer 3 pingable, and their addresses. Also the security zones look like they're set right. So now we're going to go over here to virtual routers on the side. We have this virtual router called default. I'm going to go to this one. You can see it has both of the interfaces in it. You need to go to static routes to tell it where the upstream internet actually is. I'm going to add a static route. So this is going to be called the default route to 0.0.0.0/0, which means everything. Next hop is going to be 10.20.0.1, so that's the IP of the main router for DefSec. Then this is going to be on Ethernet 1.1, which is our WAN interface. So that's our upstream gateway where internet will where all our traffic will go if it wants to go to the open internet and not just to something in the local network. Right, so now we have both of those. Now we need to set up our security policies again. I'll get to that in a sec. So security policies, we want to do intrazone. Going to override this one again to allow. So this will allow traffic to go through. We will add firewall rules later, or should add firewall rules later, but just for now, we're going to allow this. Allow all. So now we're going to set up NAT. So NAT is that mapping of 10.20.teamnumber.boxip to 192.168.0.boxip. So we're going to add new NAT. Maybe. There we go. So let's call this one NAT. So the original packet is going to come from the LAN, go to the WAN, and then the address, the original address, is going to be 192.168.0.1/24. So this is anything on 192.168.0.box number. We go to, so this is going to take stuff from LAN to WAN that has this IP address. Go to translated packet. Translation type is going to be static, since we always know what we want these addresses to be. So we're going to map it to 10.20.1.the box IP, so that's going to be just .1/24, saying that it takes that last one for the box IP. And we're going to make this bidirectional, meaning that if you come from the WAN, then you get the same thing. So it doesn't really matter if you apply it to the LAN or the WAN in the original packet one. You just need to make sure that one of them's WAN, one of them's LAN, and bidirectional is checked. So we apply this. Next, we're going to go back to network quickly and go to DHCP. So DHCP, that's how you get an IP address. Your box broadcasts, hey, I need an IP address, and then this is configuring the Palo to answer that and give you an IP address. Most of our servers use static IP, but if there's any client boxes, or if we want our GUI box to be able to connect, which is a client box, then it's nice to have a dynamic IP address. So we're going to give this, the range is 192.168.0.100. To 192.168.0.200, let's just say. So give it a nice chunk of about 100 IPs. This is going to be on the interface Ethernet 1.2, so that's on our LAN interface. Then under options, the gateway, so that's going to be the default gateway that it tells things to send traffic to, so that's going to be 192.168.0.1, which is the LAN interface on our Palo. Subnet mask 255.255.255.0. Not really sure why they switch between subnet masks and CIDR notation, but cool. For primary DNS, we're just going to set this to iLab, and yeah, everything else here looks good. So it's auto, and giving an IP in this range with these settings. Now, I think, yes, the default policy, already got that one. So changing the security policy to allow. Now, hopefully, it's actually going to work this time. Let's see how fast this is. Oh boy. Super high speed. Not really sure why it takes so long to commit. Like, I'm not sure what it's doing. Ah, 99%. Nice. Still have our IP address from the old DHCP, which is, yeah, that works. Let's see, is it going to kick us off? Sometimes it will send out a thing removing everyone's DHCP address. Sometimes it won't. This time it looks like it did not. All right, so if we do sudo and try to get a new DHCP address, looks like, there we go, we got a renewal, and this renewal is for a lot of seconds because we set that to unlimited. So it looks like we can communicate with that. Let's see, can we ping an upstream router? Yes, we can ping the DefSec routing router. Well, actually, DefSec routing is at 100.1, I think, maybe 101. 101.1. That's the actual DefSec router, but our VApp DefSec router is .20.0.1. And then we should be able to ping Cloudflare. So, now we have routing. Woo! Yay, it works. All right, so back to those security policies I was talking about. So currently, we just have this allow all rule. All traffic can go through. So if we go to the scoring engine, this VApp has a scoring engine in it, it's not going to work. Okay, why does it not work? That's concerning. Interesting. Yay, more live debugging. The scoring engine is up. Is it plugged into the right network? Hopefully. So our router's up, and the scoring engine is plugged into the right network. All right. Interesting. Not sure why that isn't working. Let's try hopping on the Kali box. So there's also the Kali box for the attacker here. Login's going to be Kali. Could just be that it's taken a sec to realize that it can talk to everything again. 10.30.0.1, that can talk. 10. That can also talk. All right. And that can talk. Sweet. There we go. Interesting. Not sure why the scoring engine is down.
So I went on the scoring engine box, and the scoring engine just isn't on it. So I don't know where you got this image from.
Huh. That's concerning. All right. Possibly that box got reverted to snapshot when it deployed, though. I don't know why that would have happened, because I only reverted the Palo to snapshot. Interesting. Well, scoring engine got nuked. Luckily, we should be able to access all the boxes from this box as well. So yeah, we can see our super sick website hosted from inside our network on .10, which is, I think that's Voyager, I want to say.
Yeah.
So this screen went bad again. Right, so let's say that we wanted to, well, block that off, because maybe we didn't want Red Team to be able to see our super fancy website. We would have to add a rule for that. So go. All right, so this is when we're adding a rule that's not one of these two default rules. So got to give it a name. So let's say, let's allow web to Voyager. So source, we're going to want anything coming from the WAN that's going to our LAN, and its destination address is going to be 10.20.1.10. So this is what I was talking about, how you need the external IP instead of the internal IP when you have NAT set up. Then application, we're only going to allow web browsing. So if we go back over here, then if we like SSH into 10.20.1.10, then you can see we can connect on SSH and talk to it. So right now we are saying that anything from WAN can go to the LAN, this IP, but only allow the web browsing application. And then action allow, so we add that. Then we're also going to have to change this default rule back. We're going to revert it so it's deny, so just revert button right there. So we're allowing web and denying everything else. Theoretically, assuming that nothing's broken this time. Hopefully. Yeah, I'm really not sure why it takes so long. Like, pfSense and IP tables have basically instant commits, even if you're committing a bunch of things. So there we go, configuration committed successfully. So now, if we are out here, we go to web, we can refresh that and see that this site's actually working. But if we try to SSH in again, it's just going to hang here, not working. Successfully blocked that. Another red team attack avoided or blocked. So that's a rule for inbound traffic. If we want a rule for outbound traffic, right now we still wouldn't be able to access anything. So if we try to go to some website, it's just going to spin, never going to load. So let's say we wanted to do web outbound. Can do source from LAN, destination to WAN. This time we're not going to set a destination address. Application, of course, web browsing. Web browsing is one of my favorite ones since it's so simple. And then allow. So we add that, commit, wait a few years for that to commit. And oh, interesting. It like committed before it showed the progress to committing. That's kind of weird. No clue why that is. Oh no, now it's like not. Kind of strange. It like committed it briefly and then uncommitted it, and now it's recommitting it. Seems legit. So if we try to go to never SSL, then we can go through. Pretty cool. And back here, still couldn't get in on SSH. Now, let's see, what is next? I think that that's about all I have today. Yeah, so, oh yeah, we could also, so, different service. Maybe we wanted to allow something like, wanted to do SSH or something like that. There's SSH, well, maybe SSH. Ah, picked the wrong one. There we go. SSH. You can allow SSH. You can allow multiple things at the same time. So maybe you wanted to do SSH and web browsing. Maybe you wanted those from your WAN to the LAN on any box. Let's just say, and call this SSH and web. And allow that. Yeah, so lots of options there, lots of fun stuff. For the address thing, we can, maybe, so we can do, if we put in something, so say like 10.20.1.10, instead of having this IP address, which might be a little bit hard to read, we can just make a new address. So that basically allows us to say that Voyager, I am bad at spelling, is at 10.20.1.10. And then now we can just say Voyager here. So in the rule, it will show up as Voyager instead of as that IP address. Yeah, I think that's about all I have. Any questions, comments, concerns, thoughts? Did anyone's virtual environment work? If anyone was following along. All right.
Woo, yay, woohoo, yeah,
Really
yeah.
social. Thanks for coming to DefSec. We will be meeting again next week, and don't forget to sign up for competition.
This is literally just the CCGC team and Mr. Swenson.